Hi everybody, Professor Gusimi here. This week we will be discussing some advanced concepts in JavaScript. And as always, there is a set of recommended readings that are associated with this lecture. Instead of posting the URLs here as I've done in some of the previous lectures, I thought it was best to just direct you to the course Git repository where there are convenient hyperlinks that you can click and it will direct you immediately to the corresponding readings that I, of course, strongly encourage you to take a look at. Those readings are all from developer.mozilla.org, and it's really wonderful content, so please do check it out. The first thing we're going to be speaking about in the lecture today is DOM manipulation. Now, you may recall from the previous lecture that the DOM refers to Document Object Model, and it's a set of APIs that are responsible for HTML and CSS styling. So taking a step back, recall that when your browser makes an HTTP request to some server, it receives an HTML document. The HTML document contains some links and maybe calls some JavaScript scripts, and it goes in a secondary capacity, collects those. And what your browser does next is it takes the HTML and the CSS and it converts that into the document object model, which is a representation of the HTML and CSS that's easy for a programming language like JavaScript to interact and play with. As an example, I'm showing here on the bottom left some HTML. It's a very simple HTML document with a short head and a short body. And I'm showing you on the right-hand side the corresponding DOM tree structure that would be generated from this HTML document. You can see, for example, there's a section here on the left, and correspondingly on the right, there is a section. Within this section, there is an image, and within the section here, there is an image, which is followed by a P, and it's followed by a P, within which is an A, and so on. Now, each element and bit of text in these documents has its own tree entry called a node. So the section is a node, the body is a node, the image is a node, all of these are nodes. You're going to encounter this reference to objects within the tree as nodes as you explore the web and learn more about web application development even beyond this course. So I think it's worth taking a few minutes to just go over some of this terminology together so that you're acquainted with it. The first thing is there's element nodes, and this is just any element as it exists in the DOM. So section, image, P, these are all element nodes. The root node is the top node in the tree. In this case, it's HTML. A child node is a node that's directly inside of another node. So for example, the image is directly inside of the section. You can see that. It's immediately within it. A descendant node is a node that's anywhere inside of another node, recursively. So image is a descendant of body, but it is not a child of body. It's a child of the section, as you can see on the right-hand side there. Okay, a parent node is a node which has another node inside of it. So body, in this case, is the parent of the section. Sibling nodes are nodes that sit on the same level. So the IMG and the P here, because they're at the same level in the tree, are called siblings. And then, of course, there are text nodes, which are indicated by this hashtag text, followed by the corresponding value. When you are using the document object model and manipulating it in JavaScript, you're going to actually see reference to sibling, parent, text nodes, descendants, child, and so on. And so if you're going to manipulate the document object model, being familiar with this terminology will make that easier for you, is my hope. So let's go through some of the basics of document object model manipulation. We did touch on this last week through some of the interactive exercises we did in the last lecture. but I think it's worth just going over it very slowly here before we get into some of the advanced topics. When you want to execute an action on the DOM, it effectively always starts with something like this. You basically in JavaScript put the word document followed by a dot to select either a method or a property of that object. In this case, one of the things you'll do to select DOM elements using CSS selectors actually is to use the query selector method. Okay, and as I'm showing here on the bottom right hand side with a very simple HTML document on the top and some simple JavaScript at the bottom, you can use the query selector to identify and bind to an element within the HTML document using CSS selector style notation. So remember from the selector lecture that we did on CSS, the hashtag here refers to an ID. So what this document query selector line is doing is it's saying, let's go find within this document an element that has an ID mylink. And if we came up here, we could see it's this A tag here, right? With an ID mylink. We then have two additional lines of code here that do what? Well, the first one says, let's take the text context of that link, which again is this A tag. And the text context refers to what's within the A tag. That's the text node that we saw earlier. And we're resetting that. Instead of it saying my web page, which was the default that was there, we're changing it to say my lab web page. And we're also taking the href property, which is this attribute here that you can see in the default, and we're also resetting that to go to, instead of my original personal web page, to my laboratory web page that you can see here. I want to note that as you execute the HTML and CSS JavaScript combination here, the page will initially be rendered this way, but JavaScript ends up modifying it so that ultimately what you get is what's shown here at the bottom left, which no longer has my web page within the hyperlink, but now it says my lab web page, and it will link to the corresponding site I'm showing here on the bottom right. It's important to keep in mind that when you're trying to select objects on the DOM, you're going to see other ways to do it. For example, you can get an element by its ID, and there's several other methods that you can use. I do encourage you to use the query selector because it will help you sort of keep one consistent way of doing your selections in mind based on CSS classes. So in addition to being able to query for nodes, there's also methods within the DOM for creating and placing new nodes. Okay? What I'm showing here on the right-hand side is a modification of the code that we had earlier. So a lot of this is the same. You can see we still have that same HTML document at the top, but I've added or changed some of the JavaScript. So let's go through it together. One of the things we have here is a constant variable, sect, which is selected from this HTML document, the section tag. So that means we've sort of bound to this, and we have that bound to this sect variable in JavaScript. The second thing we do is we create a new element, a p element in this case, that we store in this para constant. We set within that para constant element, which is blank when you initially create it, some text context, which we saw before, right? That's what exists between the tags. And in this case, it says, we hope you enjoyed the ride. We can then go to the section context, and we can append, as a child, that paragraph that we just created, the para constant. And if we do that, it will go to the DOM and it will inject that as a child within this sect. Looking here on the left, the reason we have two lines here in terms of what gets displayed is we have the first line that came from the original HTML, and this second line, up till here at least, is actually the consequence of these first four lines of JavaScript here on the right. Okay, so when we appended the child, it's what created this line here on the left. But as you can see here, we also ended up appending some more information. We had this -wisdom text that we added to both of the lines. Well, how did we do that? That's what these remaining 4 or so lines of JavaScript are for. So what we did next is we created a new constant variable called Perez. And this time, instead of using a query selector, we did a query selector all. And what query selector all does, as the name implies, is it gives you an array of selected elements so that you can iterate over those and perform operations on the ith element or all the elements as you wish. In this case, we want to select all of the p elements. And there's going to be 2, right? There's one up here in the original HTML document, but then earlier in the JavaScript, we appended a paragraph, a p element that we had created. So when we run this line, we're actually going to select 2 p tags there. And the next bit of JavaScript says for each of those p tags, let's go ahead and create a text node, which is just some blank text without an element. And we're going to append that as a child to the p, so it goes within the p tag. And that's the reason why here in the bottom left, we have 2 lines as well as the -wisdom. So this is an example of creating new elements in text nodes using JavaScript. There's also a way to move and remove nodes. This is done typically by node.removeChild and element.remove. But there are, of course, other DOM methods that allow you to manipulate things, clone things, and so on. Let's come back here to the example. The HTML here is the same as what we had before. And the first 10 lines of JavaScript here, line 1 through 10 that I'm showing, are identical to what we had in the previous slide. So nothing here has changed, except for these last 3 lines of code in JavaScript, which do the following thing. The first thing goes to sect, which, as you can remember up here, is the const that's bound to the section. That's this. And then what we say is we want to remove the child para. Okay, well, what's para? Oh, that's this. That's the "we hoped you enjoyed the ride" element that we appended to the end previously. And so we say here that we want to remove that, and so once we've done that, it's gone. Okay, we can also accomplish this through const ll, meaning we want a constant variable ll, which is just some nonsense name for now. And then we could select formally my link, and we could remove that as well. Meaning we could formally remove this particular link to my web page if we ran this line, which is not shown here on the left. It's also possible to manipulate CSS style in a variety of ways. So the easiest way to manipulate the styles is with the element.setAttribute method. This takes 2 arguments, the attribute you want to set and the value you want to set it to. So let's return back now to the right-hand side example. The HTML here is the same as before, and most of the JavaScript here is also the same. We have that sect and para constants. We still have the same text context of the para. We still append it. But the difference here is that within our JavaScript, we did set attribute that I just mentioned here earlier. And in this case, we said we want to set the class to be highlight. And as you can see here in our CSS, we've declared what exactly we mean by highlight from a style perspective. And so in this way, in one line, we're able to very quickly and easily in JavaScript make a big change to the style. I want to note here, there are ways to also, in JavaScript, manually change the color, the background color, the padding, the width, and the text align center. You could technically do all of that within JavaScript by accessing portions of the DOM. I do not recommend you do that because from a programming practice perspective, you want to, as much as possible, keep styling information squarely within the domain of CSS and not have JavaScript be doing too much of the heavy lifting when it comes to setting up or configuring styles, other than switching between things that you've defined within your CSS framework, as I'm showing here. So here in this introductory piece of the lecture, there's really three things I want you to conclude. The first is that document object model is a set of APIs for controlling HTML and styling information. The second thing is that each element and bit of text in the document has its own DOM entry called a node, and you'll hear node get referenced to in many contexts as you do work on web development. And the third real thing is that there are functions and methods within the DOM that allow you to select, modify, add, and remove elements in HTML as well as CSS. So moving on to the next component of our lecture, I'd like to speak just very briefly about how you draw graphics using JavaScript. And effectively, drawing graphics in JavaScript is all about the use of the Canvas API. The Canvas API was invented by Apple in around 2004, and all other browsers followed by implementing it over the years subsequently. The Canvas API largely focuses on 2D graphics, so drawing things like what you're seeing on the right-hand side there with the GIF, that's what Canvas API allows you to do completely within the context of your HTML document. You can also do 3D renderings, which we're not going to be speaking about today. It gets kind of advanced very quickly and should probably be the topic of its own course. The way you do 3D rendering, though, in case you're interested in exploring those capabilities, there's something called the WebGL API. Definitely worth taking a look at. So let's go through a couple of examples, complete code examples for how you use Canvas. What I have there on the right-hand side is the bare bones skeleton that you will need if you want to use the canvas. That's the HTML here on the top. I'm not showing here, by the way, the HTML tag, the head, the meta information, and so on. I'm going to assume here, and maybe in some of the other lectures moving forward, that you're familiar with the basic skeleton in an HTML document. And if I omit certain parts of that just for illustrative purposes, that hopefully you'll know that it exists within the context of HTML. Okay, so having said that, we have here a canvas tag, and you can see it has a class attribute, which is my canvas. Now, of course, this dictates something about the CSS. We come down here to the CSS, and you can see there's nothing here quite yet. There is a body. That body, which dictates this document, has a margin 0 and an overflow that is hidden. That's just to make this canvas uniform, no scroll bars, no white space around the edges, and so on. Okay, now coming within JavaScript here in the middle, there's a couple of things we do. The first thing is we declare a constant called canvas, and we bind that to the canvas class up here. Aha, that's what this class was for. We weren't using it for styling, as you can see, but we were using it so that we could attach to it using the query selector, as I mentioned earlier. Okay, so I wanted to highlight this particular example because if you're reading other people's code, there could be instances where a class is declared and you don't see a corresponding entry in the CSS. And this could be the reason. So just keep that in mind. The next thing we're going to do now that we have the canvas selected is we're going to declare a couple of variables, a width, which is just equal to the canvas.width, which is itself equal to the size of the windows, inner windows width. So that's the width of the canvas that you see down here that I'm rendering at the bottom left. And we're going to set the height as the window's inner height. We're then going to have a variable called CTX. This contains an object, and all drawing operations on the canvas involve manipulating this CTX object. You initialize it by setting it equal to canvas.getContext2D, which basically says we want to do a 2D drawing on this canvas. So after you've done this, you now have an ability to draw on the canvas, and I'm showing you the first simplest example of that. I can do ctx.fillStyle, specify a color. In this case, it's going to give me a lovely shade of gray that you see here on the bottom left. And then I'm going to fill the canvas with a rectangle. And I say I want to start at the 0, 0 position and make a rectangle of size width and height, which is the whole canvas. The 0, 0 position on a canvas, by the way, is here at the top left. So we're basically taking a gray rectangle and we're spreading it over the entire canvas using these two lines. Now, if you understood that first simple example, from there, building images or drawing rather on the canvas is just a matter of daisy chaining operations on CTX. Notice here on the code on the right, everything here is the same, except that instead of filling the screen with one large gray rectangle, I now have these 3 blocks, these CTX blocks, right? I choose a fill style, that's a color of the block. In this case, for example, we have red. And then I choose where to put that. In this case, I say I want to go 50-50 from the X, Y, 0, 0 position. So I move 50, 50 to get here. And then I want to draw an object which is 100 by 150. That's why it's thinner than it is tall, because it's 100 in width and 150 in height from this position. Okay, you have to, when you're thinking about drawing in the canvas, you're always starting up here and you're moving this direction along X and Y. You're moving outward, sort of to the right and down. Okay, so we draw the red box with this one. We can then draw a green box with the next one, which you see here, which follows the same sort of logic. It's 75, 75, so it's protruded out more than the red box. It's also smaller and uniform in size. And then finally, we have a third one, which is in this case a mixture of 2 colors, and we've changed the opacity, which is this 4th element within the RGBA. This opacity, you see, makes it so that we can see the other 2 boxes slightly behind this. It sort of changes how transparent the purple is here. Within Canvas, there is something called a stroke style, and this allows you to draw basically an empty box, an empty line. If you want to set the style of the stroke, that's the color in this case, you can do that by, again, calling RGB or RGBA if you want to add some transparent properties to it, and specifying the colors. You can then use, in this case, stroke rect to draw the rectangular box here. If you want to do anything with Canvas that's more complex than just drawing rectangles, of course, you'll need to use something called a path. And what I'd like to do to help you obtain an intuition for how the path works is step you through a block of code on the bottom right there. Now I want to note that I'm only showing the JavaScript, but I'm using the same HTML as I was using previously. So if you're going to, for example, implement this, which I suggest you do to learn some of these concepts, then just note that I've not changed anything about the HTML or the CSS for these examples. Okay, the main thing that I want to note here is that if you want to deal with drawing a path, which gives us access to things that are much bigger or much more varied, I should say, than a simple rectangle, the first thing you want to do is set what's called the path color. That's whatever object you're going to be drawing, whether it's a triangle, a circle, some random object, you want to tell it what color you want that object to be. In this case, we set the RGB, which, by the way, this sort of implies the ordering that you have here. This number is always between 0 and 255, as you probably ascertained from the previous examples. And the first one, this 255, is the R. The second one in the list is the G. And the third one in the list is the B. So the name of the function sort of tells you actually what the order of the elements are within here, in case you ever forget. Okay, so the first thing we do here is we say we want the color to be red, and then we start drawing the path. Okay, so to start drawing a path, you call ctx.beginPath, and then that might start you at some position, for example, here, and then you will move to a position using this move to. So if we were at the top left here, maybe we move 50-50 and we get here. And then we say we want to do a line from here to 150-50, which is, for example, this line here at the top of the triangle. We can then do a little bit of math to figure out the height of this triangle. If we want it to be, we want the length of all three sides to be equal. We can do some math to figure out what the appropriate offset is so that we can construct where we need to move to draw this next line. So that's in this case 100, so halfway down this line here. And then it's going to be the 50 that we were already moved to this direction, right? Plus whatever the height of the triangle is, and we get here. Okay, we then draw a final line back to 50-50. So you can see here, just to be clear, we began a path, we moved 50-50, not drawing a line. Then we made three lines, a first line this way, a second line this way, and a third line to complete it. When we call ctx.fill, we then get the triangle that you're seeing here. Now, a path is great, but it only allows us to draw in lines. And that's great for a lot of things that we may want to draw, but it's not so great if you want to draw something circular. And so to draw circular objects, there's a separate method called arc. And I'm showing you on the right-hand side here, again, some JavaScript that will hopefully illustrate how the arc method works. So let's go through this together. Just as before, we're going to start by setting a fill style. And we're going to, in this case, draw a rectangle. Now, this first block in the canvas up here is actually setting the background to be black. RGB was 0, 0, 0. And I said, starting from 0, 0 here, draw something width and height, a whole box. So we plopped a black rectangle as the background image here for the canvas. Okay, the next thing we did is we said, let's go ahead and start a path. We want that path to be yellow because we're going to be drawing this object here. And then we begin the path. The next thing we do is we call this ctx.arc. And what you're going to notice here is that there are several parameters. There's 6 of them in total. What I've done is here on the left, I've listed what those 6 parameters mean. The first 2 specify the position of the arc center. So that's the X and Y respectively. So in this case, that's this point here, the 200, 106. Okay, the third is the circle's radius. So this radius here, this distance from here to the edge, is the 50 that's dictated here. And then what we say is the third and fourth are the start and end angles at which to draw the circle. So if we drew from 0 to 360, it'd be a full circle. In this case, I want to go from minus 45, which is here, all the way over to the 45 position. So I'm sorry, from here all the way up to here. And then the last thing here defines whether the circle should be drawn counterclockwise or clockwise. False is clockwise, true is counterclockwise. Okay, then after we've done this, we've drawn at this point a line like this, and we need to complete our little Pac-Man here, we need to draw a straight line from here. So we can use the line2 function that we saw previously in the last slide and draw that to the center that we have here. That's the 200, 106. It's the same center point we had in the arc. So we do that here. And when you call fill, it will automatically take care of closing this line to the starting point. And you get the little Pac-Man in yellow that you see here. Okay, the next thing we wanted to do was Pac-Man needs something to eat. So in this case, maybe we have these 3 dots for him to eat, like in the old game. And you can see I've got 3 blocks down here that respectively generate 3 white circles, RGB 255 each time. And here we move from 0 to 360 to get a complete circle. And all we've really done each time is we've offset the x-coordinate that we want to start the center of the circle at, 400, 500, and 600 respectively. So this is how you use the arc method. Canvas also has some cool features for drawing text. So you can use the fill text and the stroke text to draw fill text outlines and stroke text outlines respectively. I'm showing here on the right-hand side from the same canvas that we looked at earlier, an example of placing the word Pac-Man or the words Pac-Man food into the canvas. And these last 2 lines at the bottom of the screen illustrate how you do that. The main thing I'd like you to take away from this component of the lecture is that there are some really incredible APIs that are built into your browser that allow you to draw things. You could, using some of these functionalities, and many people do, create games that are fully based out of your browser, create artwork and websites that, for example, leverage Canvas to do very interesting artistic things. If you want to draw anything more complex than a rectangle, of course, the one thing I hope you will remember here is that you should use a path. If you need to draw circles, you use an arc. And that Canvas also allows you to draw text. So moving to the next component of our lecture, we're going to be speaking about client-side storage. So first, let's discuss what is client-side storage. Now, JavaScript has APIs that allow you to store data on the client and retrieve it when you need it. There's some question that you might have if this is your first time hearing about client-side storage about, well, why would I even need to store anything in the first place? And it really boils down usually to 3 reasons. The first is personalizing your site's preferences. So you might want to, for example, remember or store some data somewhere that says what kind of color, like, you want the banner of someone's site to be. Maybe they can select that as an option in your website. Maybe they can change the font size somewhere in your options, stuff like that. You want a way to take some information that the user communicated to you, store that information somewhere, and then maybe access it with JavaScript so that you can do some modifications to the DOM, right? You can update some classes of your paragraphs to make the text larger or highlight certain things, and so on and so forth. Okay, so the first reason that you need to store data when you're building these websites is for personalizing your site preferences. The second thing is persisting previous site activity. So when you're navigating Amazon.com as an example, you don't have to click buy on each of the pages that you want to buy an item for. You add it to something called a shopping cart usually, and then Amazon just remembers for you what it is that was in your cart. Okay, this also happens when you log into websites. If, for example, you've logged into your Gmail, you don't have to, every time you visit Gmail or refresh the page, log in. And that's because there is some information stored on your browser that is created by those services that allows them to identify who you are or keeps track of certain things that you had done on their site. And they use client-side storage for that. Okay, the third thing is saving data and assets locally. So we're going to be speaking to this third point a little bit more towards the end of the semester, I hope. But depending on the kind of web application you're developing, speed can become a bottleneck really fast. So put yourself in the position of a site like YouTube. You have to distribute, terabytes, if not petabytes of data on a daily basis to all these people who are making very data intensive requests from you all the time. And so sometimes it's valuable to, if people, for example, watch a video multiple times, like let's say it's music, it might be useful to store some of that data on the user's machine somewhere. You want to store it basically on the client side and just tell the client, hey, I already gave you that file. I already sent it to you. Why don't you just go play it from your local ecosystem instead of having me transmit it to you again over the web? Okay, so these are sort of the three reasons why you have client-side storage. Now, those are three reasons for why you have the storage, but in terms of the approaches you can use to get client-side storage, there's 4 of them. And I'm not going to talk about all 4 of them for reasons that I will explain in a minute. 2 of these, cookies and web storage API, are things that are probably easy for you to understand without us having gone through databases in this course yet. The IndexedDB API and the Cache API, which are respectively a client-side database system that's really powerful and a way to sort of store HTTP responses to specific requests. They're excellent tools. I really suggest that you look into them. But I think at this point in our course, there's really only the first 2 that I'd like you to learn. Cookies for kind of historical reasons and so that you're aware. And then web storage API is really the one that I think is most important for you to be familiar with if you're truly just trying to do client-side storage. So let's speak about those first 2 over the next couple of slides. Let's start with the old school one, which is the HTTP cookie. Now, since the early days of the web, sites have been using these things called cookies as a way to personalize users' experiences on websites. And all a cookie is it's a small piece of data that the server sends to the user's browser. And the browser may store this cookie and then send it back to the same server with a later request. And this is because, HTTP requests are stateless, right? We covered that in, I think it was the second lecture that we did together. This image here on the right is meant to illustrate kind of how that communication works. So when your browser first visits, or when you rather first make a request to go see a web page of some kind, your browser converts that to HTTP and the server sends back the page. So that's the HTML. But it could also send back to you a cookie. And the nature of cookies is that the next time you make a request to that server, the cookie can get passed along. That web server can then, because that cookie, it can put something in it the first time it sends it to you, they could use it to identify you. They could know, for example, after you've logged in to gmail.com that, oh, this is Jack or Mohammed or Tom or whoever it is. And then when you continue to navigate pages, because you're always sending that with your HTTP request, it persists for the purpose of recognizing who you are. Cookies are used mainly for 3 purposes. There's session management, so logins, anything that the server wants to remember about you. There's personalization, which we spoke about a little earlier, and then there's tracking. So understanding how you move around the web, cookies are used for that. You can actually use JavaScript to access cookies in the document object. It's pretty simple. You actually just call document.cookie and you will get something exactly like what you see here on the bottom of the screen. Actually, if you do this in your browser on google.com or Facebook or a lot of other sites that you might use, you're probably not going to see something that looks like that. I intentionally fabricated this cookie so that it would be easy to read. The ones you're going to see if you go to an actual website are going to look like a bunch of gobbledygook nonsense because they're either encrypted or they're employing security through obscurity by making the elements of the cookie, the key value pairs, difficult to read. So let's try to understand, though, fundamentally what a cookie is by looking at this string down here. Note that there's some structure here. There's always an element followed by an equal sign, followed by an element, a semicolon, a space, and then the pattern repeats up until the last element here where there's no semicolon. Well, that's because this is just a semicolon space separated list. And each of the elements in the list, there is a key value pair. The key is the element on the left. In this case, test1 is sort of the key. And the value is hello. And you can have as many of these elements within the cookie as you want up until some point. Cookies are not infinitely large in terms of size, but you can store quite a lot of text within them. You can also add cookies actually from JavaScript by using the commands that I'm showing you actually right down here. You can say document.cookie equals, and then you put sort of these three elements, the key value pair you want for the cookie, and then two other options among a set of other options that you could put in. And I'm going to try to explain what those mean because they'll give you some intuition for how cookies work. So first thing I want to say is that when you write to document.cookie in JavaScript, you're not replacing that string you saw earlier. You're appending to that string, which is a little counterintuitive first time you see it. The second thing is that these other two entries in this, what looks like the list, don't actually get appended onto the cookie. So if you were to display the new cookie, it would be what we saw before, plus this key value pair, name, Oscar. The other two key value pairs that you see here, or I guess the last one's not really a key value pair, but it's kind of a key, are parameters that govern some of the properties of this cookie that your browser is going to remember. The first one is this same site, and you can see we've set it equal to none. Same site controls if the browser is going to share that cookie for cross-site requests. So it means when the server generates this cookie and sends it, it's effectively saying, do you want to allow this cookie to be shared with other websites? Let's say Facebook issues you a cookie. They could specify within that cookie that, yeah, I'm okay sharing this with anyone that you make an HTTP request to. You can share it with Google. You can share it with Professor Ghassemi's website. You can share it with anyone. And then whatever's in that cookie will be sent to me when you make an HTTP request to my website, as an example. The way that that's specified is with these three parameters. There's lax, which is you can send this cookie in an HTTP request browser for all same site requests. So if it's the same website, send it. There's strict, which prevents the cookie from being sent by the browser in all cross-site browsing contexts. And then there's none, which basically is do whatever you want, send it in every request, both cross-site and same site. Okay, you under almost no circumstance want to use this third one. If you are issuing the cookie, there could be some special reasons you might want to do that, but usually it's a very bad idea to include this none tag here, which is what I'm showing on the screen. The other option or parameter here is secure. And what this says is that the cookie can only be transmitted over HTTPS. Now, when we went over HTTP, we didn't talk about HTTPS. A simple way for you to understand what differentiates the two is that HTTPS is an encrypted version of HTTP. So because of the way that the internet shares information, as we mentioned before, you're kind of bouncing it around from machine to machine. The machines that are sitting in between you and where you want to send or receive information from could technically open up the message and look at it. They could look at the HTTP request. So if it's not encrypted and there's sensitive information in there, it could put you at risk. That's one of the reasons why when you're dealing with cookies, because they get sent back and forth and they oftentimes have some sensitive information within them, you almost always, when you're generating the cookie, want to use this secure parameter. I do want to note a couple of security and I should call them legal elements of using cookies. The first one is that from a practical perspective, you can't access cookies from JavaScript if the HTTP only flag is set. Okay, so keep in mind that cookies are not always editable, depending on how they were set up in JavaScript. Also keep in mind that when you store information in a cookie, if you choose to do this for a website you're building, that cookie is on the client's machine. So they can open it, they can edit it, they can modify it, and so on. There's ways to assess if it's been tampered with. There are some ways to do that, but you probably don't want to deal with that. So just know as you're building a website, if you're going to use cookies to store information on your users, just understand that they can be tampered with. When you're issuing a cookie, I suggest that you do, in fact, use the HTTP only attribute so that your users and potential malware they might have in their machine are not able to access the cookie values via JavaScript. I also suggest that you place an expiration date on those cookies, and if you're going to use the same site attribute, set it to either strict or lax, not none, like we described earlier. Lastly, there is legislation that is practically effective everywhere, or there may be a couple places it's not, but to the best of my knowledge, most places have regulations about the use of cookies. So these are actual laws, and if you don't follow them, it could get you in trouble. You've probably heard of GDPR, which is the General Data Privacy Regulation Act in the European Union. There's the e-privacy directive and the California Consumer Privacy Act. All of these basically force you to disclose to the user that you are tracking them using cookies or storing information on them using cookies. So be familiar with some of these rules if you decide to use cookies as part of your service. Now, I spoke a lot about cookies because I think it's a technology that, as you go about developing websites, either for an employer or your own website, you're going to encounter them for sure. And I just wanted to make some of the nuances of that technology familiar to you. What I personally think is that if you don't have to resend the information back to your server every time a request is made, it's actually better to just keep all that data stored on the client side and just persist it there. There is a way to do that, and it's actually very simple. It's called the Web Storage API. It provides mechanisms for your browser to store that same key value pair style information that was in the cookies, but it's actually significantly more intuitive to use than a cookie is. There's basically three functions. There's storage.setItem. This allows you to save a data item in storage. So once you call this name value pair is stored, but it's stored only for the particular website that you called this storage.setItem on. So if you had some JavaScript on your website and you wanted to, for the user that obtained your application, you wanted to store some data on them based on ways they had interacted with your site or preferences they had set, or a name that they had typed in about themselves. You wanted to kind of store that so you could use it in other places. You can use the Web Storage API to set those entries. Of course, once you've set them, you need a way to get them. And you can do that in JavaScript by using local storage.getItem. In this case, if we called name, it would go and fetch Chris. And just to be totally clear here, the thing about web storage is that if you close the browser, if you refresh things, that storage item will persist in your user's browser. So if you're going to be distributing web applications that don't have a lot of server-side interaction that you're doing, Web Storage API is a really great way to create applications that remember things about how the user has interacted with it without having to run back to your server and ask for more information. Of course, you don't want to persist items potentially in that storage forever, so there's also methods to remove items that you have here. So the major thing I wanted you to conclude from this is that the JavaScript API, or JavaScript has APIs rather, that allow you to store data on the client and to retrieve that data when you need it. In short order here, we're going to be speaking more about the back end, and data is going to become increasingly important. But just know here, before we leave sort of our walled garden of thinking about the front end and transition into conversations about the back end, that there are ways to create web applications that don't need a formal database system that you are managing. You can do a lot of those things on the client side if you're okay with keeping the data on the client side. I also want you to sort of understand intuitively, but you may not have to use them very much in this course, what are cookies and how they can be used to personalize user experiences on website. I'd like you to know that you can interact with those cookies using JavaScript, and that the web storage API is probably a better way to store information about your client than using a cookie is. Okay, so the next component of the lecture is about client-side frameworks. Now, if you start reading popular web development blogs, or you follow sort of folks who do web development kind of as a full-time profession, you're going to hear about this thing called a single page application, or an SPA. And basically what an SPA is it's this kind of modern take on building a web application where the web application loads a single HTML shell and then basically uses JavaScript to continuously update the document object model inside of it. We saw an example of that at the beginning, right? You can use JavaScript, you can edit the DOM, you can highlight things, remove elements, add nodes, and so on and so forth. We went through all that together. And so the idea here is that because those can be done in JavaScript, actually all you really need to do from a client perspective is make an initial request, and the server is going to send you back some HTML. And then from there on, and don't worry about how this is done yet, we will talk about it as we get into the back end. From then on, when you make requests to the server to collect a new page or something of that kind, the server doesn't actually send back HTML anymore. It just sends back some data that tells the client, now, what do you need to modify in the document object model to do something cool for the user's experience, and so on and so forth. So this idea of JavaScript basically taking the initial document and modifying it, extending it, and so on is what a single page application is. There's two flavors for how you build a single page application, or two ways, I guess. The first is called client-side rendering. And this is where the client requests new data from the server, and the client is responsible for updating the DOM accordingly. There's also something called server-side rendering, and this is where when the client requests some new information or an extension to the web application, the server actually renders some new HTML or content, and it sends it back to the client, and it gets plugged in. Now, I said all of that because JavaScript frameworks exist to sort of make this process of modifying the DOM, which we went over in the beginning, they exist to sort of make that simpler, more maintainable, and more predictable, which is particularly important if you have a single page application. Okay, the JavaScript frameworks are trying to help you write code that is a little bit more abstracted, so that if you get used to the framework, at least, it's easier to follow and interact with. As by way of example, let me show you some code here from regular JavaScript, which I scroll through on the gift on the right-hand side here. And this JavaScript code creates a to-do list that you see here on the bottom. So I can add items and they show up and I can delete them and so on. Now this is a lot of JavaScript. It's almost, I think, 100 lines of JavaScript that it takes to create this to-do-matic that you have down here. If you use a JavaScript framework, and there's some nuance to this, but if you're using a JavaScript framework, you can sort of build something similar in a lot less lines of code, at least from an HTML perspective, right? You don't have to sort of write as much down in order to generate the to-do list if you're using, for example, something like Vue. Okay, so frameworks are supposed to help with that simplification. Now, when you go online, if you were going to research JavaScript frameworks, and there's new ones that are coming up all the time, and in 12 months' time after we've recorded this lecture, there may yet be new ones that rise to the top of the pack. But at the time that I recorded this lecture, there are 4 big frameworks that are powering much of what people like to speak of as the modern web. And those 4 JavaScript frameworks are Ember, Angular, React, and Vue. Okay, those are the 4 big ones. Now, Ember is the oldest of those 4 frameworks. It has less users than some of the more modern alternatives like React and Vue, but it still has some popularity and it's still used by a bunch of people. Angular is a tool that was built and continues to be built by folks at Google. It extends HTML with some of its own code, and Angular's sort of primary promise to people who use the framework is that it's designed to help scale front-end single-page applications to be very high performance. Their mantra is you can go from a single developer project to an enterprise-level application. There's React. This one's done by Facebook's team, and it's kind of colloquially understood as a JavaScript framework. It's not exactly a JavaScript framework. It's kind of a conglomeration of some other things. React extends JavaScript with HTML-like syntax known as JSX, and I think it's the most challenging of these 4 frameworks to learn. It's the most involved of the 4. Fourth on the list here is Vue. Vue was actually started by somebody who was part of the Angular team and splintered off. It extends HTML with some of its own code. You're going to see in a minute here what I mean by extends HTML. Vue is the youngest of these big 4 frameworks, but it's enjoyed some recent uptick in popularity, and I actually think it's the easiest of the 4 to learn. In fact, what I will be taking you through later in the lecture is an overview of Vue.js so that you have some familiarity with that framework and can potentially use it both in this class as well as hopefully beyond this course. Before we jump into that, though, I want to talk about a couple of things to consider when you're choosing or using a framework. The first of these is please don't use a framework just for the sake of it. I know it's cool to say my project uses React, or you'll have people who say, oh, it's an Angular app, and they sort of speak about those things, but using a framework just because you want to say that you used a framework on your CV is not the right reason to use it. Because what a framework does is it leverages a larger code base, which means it's a slower code base because you have to load more of it. And what it buys you in exchange for that is some additional abstraction. So depending on how you use them, and in some cases, you can write less code if you use a framework. You'll deal with less DOM interactions like we showed at the beginning of the lecture if you use a framework. But it may not always be the case. Okay, so think carefully before you decide whether your project needs a framework. The second thing to think about is if you're going to use a framework, they're really, for the most part, focused on the client doing the heavy lifting when it comes to manipulation of the DOM. So editing the way that the styles look based on what users do, adding items to the to-do list, blah, blah, blah. Now, you could technically take care of a lot of those things on your server. You could have the server remember who a user is, using a session or a cookie as an example. You could have the server, every time the user does an action, send some updates to to the client to kind of plug those updates in and modify the DOM. Between these two, client-side rendering is definitely more common. It's considered to be more straightforward to build your applications in JavaScript rather than having these two languages that interact on the server side and the client side. But there may be circumstances where you are bound to use the server side for rendering, in which case a framework may not be necessary. Now, having said all that, certainly not in a way to discourage you from using frameworks, I would like to help us get started with Vue.js. I think it's the simplest of the four, the most intuitive to learn, and that's why I've chosen it for the purposes of this class. I really like that in Vue.js, you can progressively integrate it into your applications. You don't, for example, even need the Node package manager to install Vue.js. You can simply grab that script tag, one of those two, either for development or production, as I'm showing on the screen. You can plug that into the head of your HTML document, and that's it. It's like you've imported this framework into your web application by simply including that script. And I'm going to show you over the course of the next several slides how exactly importing that script ends up impacting the kinds of things you can do in JavaScript. So let's get started by creating what's called a Vue component. Vue components are sort of like new HTML elements that you define in JavaScript. Okay, I'm going to explain what I mean by that by taking you through this example that you see here on the page. I also want to note, before I actually take you through this example, that a lot of the code that you will see me do in the lectures and that I play around with to test things is actually done in a service called JS Fiddle, which I've pulled my browser over here and hopefully you can see it. JSFiddle.net is how you can access this, and it effectively allows you to put in HTML, JavaScript, and CSS together and see what the rendered application would look like in one of the panes here. It has a lot of other functionality that you can use to, when you're first practicing and trying to exercise your HTML, CSS, and JavaScript skills. For example, you can come here and you can enable the console, and you can see things that get printed to the console down here. Okay, we could do document as an example, and it will print the document up here, the DOM, which is a long, horrible, messy object, as we alluded to earlier. So I want to make this clear that everything I'm going to be showing you for the Vue tutorial was done here in JS Fiddle and was also done using vanilla JavaScript. So I didn't configure this environment in any special way. It should be the case that technically what you do or what I show here would work in the web application that you're building within your Docker containers for the homework. Okay, so now coming back to this Vue component, let's take a look at this example I have on the screen and try to understand what it's doing. Well, you might notice here, of course, I have an HTML document. This is pretty standard, right? There's a head, and there is some scripts to import main.js, and this is for this content down here. I have a link to import my style sheet here. And then I have a script here that's going to import Vue. That's what I showed on the previous slide, right? I want to import the Vue.js framework. That takes care of everything in the head. Now we have the body. In the body, I have a div, and I've given it an ID app. Within this, I have an H1, large header called to-do list. And then within this, you can see I have this strange HTML tag that we have never discussed, this new element, to-do item. Now, this is not an HTML element that we've ever covered in this course, and it's not one that you will find online, that's for sure. This HTML element, as you're seeing it here, is something that we created using a Vue component. And this is sort of, I think, the right way to wrap your head around the kinds of things that Vue allows you to do and the advantages that a JavaScript framework provide. What this Vue component, which is defined as I'm showing you here on the first 5 lines of JavaScript, does is it allows you to sort of create a new HTML element that you can use upstairs in the HTML document. In this case, we called it to-do item, right? Just like you have here. And we're saying here that the to-do item is actually a representation of this template here. So it's a div followed by an input of type checkbox with an ID to-do item. It has a label in it, and then it closes the div. And so at the time that the user comes to display this HTML, JavaScript, and CSS that we have here, Vue will come to this to-do item, and it will insert this template into the HTML for the user to see. Now, why would you do this? What's the point? Well, because if I wanted to add multiple items to this to-do list, for example, have 2 of them, I can do it once I've declared this down here in JavaScript once. I can just add 2 of these to-do items here, and I get 2 items in my to-do list that I'm showing here in the top right illustration, figs and grapes. But of course, with Vue, it's not just that you can make templates. I think that's one of the really nice ways so that you can keep your HTML documents easier to wrap your head around. But what's nice about Vue, as well as some of the other frameworks, is that you can make your components dynamic with properties, or props, as they call it in Vue. And effectively, props allows your component to keep track of some state information that further enhances the flexibility of the templates that you're creating, right? Because what was the issue with the template back here? Well, the issue is that when I want to insert this, it's kind of boring, right? Because every item is always going to be the same. It's always going to be my to-do item. So if I pasted in my to-do item 10 times, I would just have 10 bullets here that said my to-do items. That's not very useful. What I'd like to be able to do is pass some kind of information that would allow me to edit those, maybe with an attribute tag like you're seeing here. So more formally, in the HTML block that I'm showing here, which is based on what we saw previously, I now have the same thing, except there's 2 to-do item elements that I declared using a Vue component. And I've added an attribute to each, my item. And what you can see is that whatever I put as the value for the my item attribute shows up as the element in the to-do list when rendered. Okay, well, how did I get this to happen in Vue? What I effectively did is I came down to this props, the properties, and I declared as one of the properties of this component, the property here, that's like the attribute in HTML, that there's going to be something called my item. And I gave some further information on it, like it's required, and that the type of it is a string. So it has to be a string, or the console will actually complain at you if you try to put a non-string in there, which is good. You'd want that, right? You want to be able to specify these things and get errors that are sensible when you're debugging. Okay, I also want to note here that what I'm showing in the Vue side of things, there is a component that gets generated, and then there's this new view which binds to the top element where you're going to do your Vue operations, app in this case, which is this div ID. Okay, the hashtag, remember, is for an ID selector, and then we're basically grabbing this div. Okay, but this skeleton, this very simple skeleton, will work if you go to JS Fiddle or you do it in your own app. You'll be able to create something in Vue very simply. Okay, so this is nice, right? Because with this props, we were able to specify that there was going to be a my item attribute. But there's one piece remaining here which we didn't cover, which is, well, how exactly does this pass the my item that's here into here? How exactly does that get passed along? How does it know where to put it? And it does that because here in the template, you might notice that I changed the item within the label template here. I put this double curly braces followed by a white space followed by that same my item keyword that you have in the attributes and that matches the property. And this basically acts like an insert. It sort of injects whatever you had for the my item attribute into this template as you plop it down within the HTML document at the time of rendering. And so, for example, because my item says figs, that's the reason why the figs gets substituted in for my item here within this div that gets rendered as figs in the to-do list. Now, in addition to the properties, Vue has some data attributes as well, where you can manage the local state in a component. Okay. The reason there's a difference between properties and data is because components in Vue shouldn't alter the value of its own properties. So for example, you wouldn't want it to alter checked if it were a checkbox because it's altering its own property. Things that change after the initialization, this is the easiest way to remember it, I think, are things that should be within this data. That's how you know whether it goes in data or whether you can put it in props or not. If you're going to edit it at some point in the website, you're going to modify it, update it in some sense, you want to put it in data, not in props. Okay. Now, Vue has a special syntax to bind JavaScript expressions to HTML elements and components. It's called vbind. And I'm going to show you an example of how that works again here on the right-hand side. This is the same HTML document we had before, but you might notice there's a modification. I've put a colon here, followed by the word done equals true. Okay, so what I'd like to do is come down to the Vue component, and I'm going to highlight the things that I edited down here that were responsible for allowing me to have this done equals true translate into the checkbox being clicked here in the to-do list on the top right. So let's come to the Vue component again. Well, what I did is I added some data, and the format of this data part of a Vue component actually always looks like this. It's data, open and close parentheses. You open the curly brackets, you put return, you open a curly bracket, and that's where you start declaring the things in the data thereafter. Okay? So this is just sort of the syntax up till this point. This is where sort of the magic starts happening. Well, what we declared was a key value pair is done is this dot done. This refers to the component itself. And it's smart enough to figure out that the done here is the done property. So meaning that this dot done is actually this done property. And this done property is, it's like an attribute like we had up here, right? With a default false and a type Boolean. Again, the reason we're storing this here is because we may want to remember if a box was checked or not. We could put it up here, but you don't want to modify things in your properties. You want to keep track of the state of things in data and put the form of things in the property. So right now this data is keeping track of, is this checked or is it not checked? Okay. Because of this, we can come to the done property, we can set it to true, and this data element will be updated to record that, and we can act on it later in regular old JavaScript or using other components of Vue. We can also, within data, we could also do this within the properties, but I'm going to do it for this example in the data. We could add an ID as well. Okay, the way we would do that, automatically generate an ID for each of the elements in this to-do list, like I'm showing in the HTML block following rendering here on the bottom left. Here's the H1, that's from this, and the to-do items are turned, you can see, into these two div blocks with an input and a label and so on. Well, they have an ID, right? Because I may want each one to have a unique ID for the purposes of selection later. In order to generate that unique ID, we can do it procedurally using Vue. In this case specifically, we come to that data attribute and we say, well, we know we want to store it, right? That ID in the data. And we want that ID to be the string ID followed by just some random number that is pulled from your current date in milliseconds. So these were created 1 millisecond apart, which is why the numerical entry following this is 1 apart. I just did this so I could always create a unique ID. There's other ways to do it. So what you might notice up here is that in the input, what did I do? I bound that the type is equal to checkbox. That makes sense, right? That comes here. I put that the ID was an ID, and the an ID is from this data. So notice that this string matches the corresponding string down here. But there's a nuance here that I want to make very clear, which is notice that this ID, because it's bound to something down here, because it's bound, you have to start it with this colon operator, or you could also start it with vbind followed by the colon operator, as I'm showing on the next line. Those are equivalent. But the thing you need to remember that I think can make this confusing the first time you're doing it is that the colon operator, you're only going to use it when you're binding to something downstairs. Okay? So in this case, we're binding to an ID, and that's the reason it's there. Or in the case of whether the checked property is on, whether it starts off as checked or not, it's being determined by this is done, right? If the data says it's done, that's when it's checked. That's the way this is determined, right? Okay, hopefully that's clear. Now you can also render lists using Vue with something called v4. v4 is a built-in Vue directive that lets you basically include loops inside your template. So it's really useful. It's like being able to write a loop in HTML because of the framework. I'm showing you an example here in HTML how it's done, and then we're going to again come down to the Vue component and look at what changed so that we can understand how to do things in Vue. So what I have here is, notice how I deleted those two to-do list items I had before, and I modified the code slightly. I kept the H1, the to-do list, and then I added an unordered list, ul, and within this I have a list item, li, and here is where that special directive or attribute shows up, v4. What this v4 says is it tells us what we're going to iterate over in order to do some actions later. And what is the index of the things that we're going to iterate over? So you can see there's a v4 item in to-do items, and then the key is item.id. Let's first jump downstairs and into the JavaScript and figure out where these two things came from. Well, you see here in my new view, before in the previous screen, let me jump back, it was just this very small declaration, right? That said EL, and then it pointed to this div with ID app to initialize things. Well, we've since expanded that to include some data at the level of the view itself, not at the component level, but at the level of the view itself. So this is for sort of the whole page. We were trying to declare some data. And this data is something called to-do items, which is a list of dictionaries, as you can see here. And each of these has an item, ID, a name of the item or my item, and then it has a done indicator. This is whether the box is checked or not. And so what this v4 is doing is it's saying, go take each of the items in the to-do items down here. Go grab each of those. And the key here, if you're going to index them for the purposes of rendering and iterating through stuff, the key you should be using is this ID. So just recall that the key should have a unique value of some kind. Okay, you shouldn't have redundancy like the my item elements could, for example. Okay, then this gives us the for loop. And then what we do with this for loop is we're going to basically put down within this, for as many items as there were in this to-do list, we're going to generate one of these LIs, the LIs. And as you can see, each of these LIs has one of the to-do items that we generated as a component earlier, right? It's the same thing. But there's a couple of modifications here that are important. Because we declared a v4 here, item and to-do lists, now everything that comes before the end of the tag here can gain access to the particular item that we're referencing from this to-do list or this to-do items data. So for example, we can set the myItem attribute. You remember that. We had it in the properties before. We went through it. We can set it to be item.myItem. And this item.myItem is, if we were in the first iteration, is apples. And that's in fact what shows up here on the to-do list. We can set the done to item.done. In this case, it initializes to false. If we went to the second row, the item would be figs and the done would be true. And you can follow through and see that this effectively allows you to declare something about the state of the page in data up front. And then you get this corresponding visual of the to-do list on the right-hand side. I also want to emphasize that the really nice thing about the framework is this. If you were to update that data in the view dynamically, like in JavaScript, you went in and you changed data and you added a row, the to-do list would update automatically. The framework takes care of all of that dynamic DOM manipulation insofar as you've made the links correct. Okay? Now for the next couple of slides, so that you can see all the code, I've kind of blown up and made that panel on the right a little bit larger so that you can see everything, hopefully. And I'd like to highlight here that when you're making components, you don't have to just have one in Vue. You can obviously have many. We already spoke about this to-do item. That's this first block in JavaScript here. But we could also have another component like a to-do form. That's this block here of an input and an add button. Okay, and the simple thing that we'd start with there is a template, just like we did when we were creating the to-do item. We might call it to-do form, and we say that, hey, the HTML is going to look something like this. We can then come up to the HTML. We can plop in that new element we created, and when we compile it and run it, it's going to look like what you see here at the bottom left. We get this nice form entry for adding things to the to-do list. Now, obviously, moving from the to-do list with a static form entry and getting that to do something interesting to have an event like we have in regular JavaScript, that's sort of the missing piece here, right? Now, if we want to start dealing with events, we have to talk about methods in Vue. A method basically is something you declare at the level of a component. And the method are like the functions that are executed within this template, some actions that occur within this template object. I've highlighted here, and will for the next couple of slides so that your eyes know where to fall. I've highlighted the things that have changed so that as we speak about the various components, you know what we've already gone over in this code block and what has changed that you need to pay attention to. So there's two things here. Notice first that we added this methods to our Vue component, the to-do form. And this says that when on submit, we declared this, we wrote this on submit function, do the following thing: console.log form submitted. And then in order to bind this in order to call this basically when something is done on the form, you bind it by going to whatever the action was in the form, such as this is submit. This is an attribute of forms in HTML. You bind it by using this @ symbol. And so now basically when the form is submitted, this says, check when that form's submitted and call this on submit. Okay. The consequence will be when you click the add button from the previous slide here, if you click that button, it's going to submit the form and then do console.log and print form submitted. And that's in fact what happens. It does submit the form, but there's no server in this case for it to submit it to, so you get a 404. And then you get this form submitted that you see down here. Now, obviously, we're putting that in a form, but we don't actually want the form to submit anything to a server, which is what they do by default. And we will be speaking a little bit about forms and how they do that in next week's lecture, actually. But for now, for the sake of this to-do list, we don't want it to send information to any server. We just want it to print that console statement for now. So within events, which remember are these things that are symbolized by the @ you can modify things by using a period followed by a modification you want to make to the event. So for example, we can say we want to prevent this from happening. The submit, when submit happens, we want to prevent its standard behavior. That's what this does. And then of course we want to execute whatever happens within the block down here, which is the console log. When we do this, when we click add, we'll get the form submitted here printed in the console, but we are not going to get the 404 error that we had before. I'm highlighting the prevent event modifier here, but I also want to note that there are other event modifiers. There's some for left and right clicks and all sorts of other things that you can look at the Vue.js documentation to learn more about. To get us closer to creating an actual functional to-do list of some kind, the next thing we'll have to learn about is something called vModel, which is responsible for binding data events. Coming back here to the right-hand side, there's a couple of things I want to point out. First one is here to my input field, I've added this vModel. You can see here this attribute into the template, and I've set it equal to label. Okay, this label is not to be confused with this label, to be very clear. This label just says, I want to listen to whatever happens in this input field. I'm going to just listen to that thing, that input. So whatever gets typed in here, I'm listening to it. And I'm going to store that in a variable or data element called label. That's what it does. Well, if I want to store it in a data element, what do I need to do? Well, I need to create that data element, right? So that I can store it there. And that's why here at the bottom, I've added data, the return, which is again just syntax, and I've added label and I've initialized it to blank. Obviously the instant somebody types in here, because this vModel is listening, it's going to update to Wowza or whatever else is typed in dynamically. Okay, I've made it as well so that to kind of test this, when the submit button is clicked, we now do a console.log and we print label value, and then we take whatever's in this data label feature here. This.label pulls this. When you do that, you can see down here it actually does, in fact, work. Okay, so Vue we're at the very last step now to kind of complete this. Once you've done these bindings with the vModel, Vue can emit a custom event to pass the data along. So remember we had the vModel here, and we said we're going to listen to whatever's in the input. We're going to store it into that data attribute label down here. Now all we need to do to kind of complete this is make it so that when the submit is pressed, we use something called this.emit, which is responsible for taking this and passing it out of our immediate vicinity. And we want to emit this on through something called to-do added. And I'm going to explain this in a minute. And what we specifically want to emit, what we want to kind of pass out on the submit, is whatever the value of the label was here. Okay, this to-do added is bound to this to-do form up here. Okay, so this basically says, where do you want to put, where exactly do you want to put this element? Tell me by denoting it with this @to-do added. And in this case, we said that's right up here. And the @to-do added is going to act on that information by calling the add to do method in the main document down here. So notice we're no longer in the components now. We're now in the new Vue itself. And we've added this method, add to do. Okay, that was what was called up here, add to do, and it has a to do label. This to do label is acted on by taking whatever was passed through, that's this label that we passed through, and we're going to push the an ID X. In this case, it's just X, right? You probably, if you were building this for a real application, would want to give this a unique ID, not just X. We're going to push that to-do label, that's this here, that was passed in, which was ultimately fetched from here. And then we're going to set the state done equals false. Notice these three elements, ID, my item, and done, are getting pushed to the to-do items. That's this one that we already went through, this data, right? And the instant it gets pushed, as I'm showing in this GIF on the left-hand side, that's it. Everything updates. Vue takes care of changing the DOM, updating it, fixing everything for you. It's all good to go. Okay, so this is hopefully gives you some idea of the power of these JavaScript frameworks. So what do I want you to conclude from all this? Well, the first is that modern web page apps like to, not in all cases, but in many cases, load a single HTML shell and continually update the DOM inside of it. The second is that frameworks, whether it's Vue.js, React, or whatever framework you're using, you should think of them kind of like JavaScript libraries that help streamline some of your development process and take care of those interactions with the DOM that can take a lot of code. With respect to Vue, which is the framework that I introduced in this lecture, and I think is one of the easier ones to learn, the components can be defined in JavaScript and included as HTML elements. We saw some of that. We can add properties and data to our components, as well as to the main Vue element, and we can govern how events propagate through and impact the DOM through emissions. So with this, we've covered everything in the lecture. I want to make a quick note here at the end that as of today, we've covered all of the elements of the front end. That's HTML, CSS, the introductory components of JavaScript, and the advanced components of JavaScript. Thank you for your attention, and please feel free to reach out to me if you have any questions.